boring now.
This video is going to take a look at completing the square, specifically simplifying an expression by completing the square. So the first thing I'd like you to do is work on the warm-up for completing the square. In order to do that, I will do the first couple of each sample with you. In the first example, they're saying if in factored form a perfect square quadratic looks like x plus 1 quantity squared, the factors are going to be x plus 1 times x plus 1. The distributed version of that is x squared plus x plus 1, and in standard form x squared plus 2x plus 1. So why don't you complete the next 5 of those? And the table below asks if you can then work backwards. Well, it's saying if I have this expression here, can I then make that into a perfect square binomial? I'm looking at the patterns that I see and I'm trying to figure out what would have to go in those parentheses to make it work. So see if you can figure those out and come back and check your answers with me. So I didn't fill in this third column of the table, but I'm sure you can imagine and you have figured out what is in there. The standard form is all there, and now I would ask, did you notice the pattern? There should be a pattern that you see in that the term here is doubled here and then squared as the last constant. So in order to work backwards, you really had to look at that pattern to be able to do this. The first one was x plus 6 quantity squared, and the only difference between these two was that the middle term was negative in the second one. So that would be x minus 6 quantity squared in order to get the negative 12x. When we get to the fractional ones, it gets a little bit more challenging because what you're thinking of is really, how can I get this 9/4? Well, the square root of 9/4 is 3/2. That should be a minus here. So x minus 3/2, if I square that, what do I get? 3/2x and negative 3/2x and negative 3/2x, which is negative 6/2x, which is negative 3. So it does in fact work. It was just a minus there. And then the last one would be x plus 50 quantity squared. The final one here cannot be expressed as a product of a perfect square binomial as it stands, but we're going to learn how to fix that. So the ones above are actually called perfect square binomials because they're a binomial that's a perfect square. If we define it, a perfect square binomial can be expressed in the form a plus or minus b squared. And we already said that this cannot be done right there. But if you think about completing the square, if I have an x squared plus 8x plus 3. If I wanted this middle term to work out to be 8x, what would I have to do to my square? Well, I'd have to add a 4 there and a 4 there, and that's going to work out perfectly for my 8x because I'll get 4x here and 4x here. So far I'm in great shape. The only problem comes in with this section because 4 times 4 is 16. I have a little bit of trouble because what I'd like to do is I'd like to have x plus 4 quantity squared, but it really doesn't work out so nicely because in order for that to happen, I would have had to have a plus 16 here. So if I want to express this as x plus 4 quantity squared, what I can do is I can leave that and then just subtract 13 to balance it out. So it would be x plus 4 squared minus 13, because in essence that's the same thing as x squared plus 8x plus 16 minus 13. And then I get back what I started with, which was that expression. Let's take a look at how this works. Basically what you're doing is you're taking half of the middle term and you're squaring it, and then you need to find out what you need to subtract to balance out what you already had there. So in this case I would want this to be a minus 2 quantity squared, and that's going to give me a squared minus 4a minus 4, but I want it to be plus 15. So what can I do to balance out that minus 4? Well, I had the 15 there, and then what I want to do is subtract out that 4, because then I would get a minus 2 quantity squared plus 11. It's basically, this part is just to balance out what you overcompensated for in there. Let's try number 2. I would like to have n minus 1 quantity squared. In doing that, I get n squared minus 2n, and then I get plus 1. Well, I didn't want plus 1, I wanted minus 15. So I really know here that I need to subtract 16. So essentially what I'm doing is I'm tacking on that minus 15 and then minus 1, which is the square of this number. Let's keep going. I know that you're a little confused right now, but stick with me, okay? Number 3. So I'm going to take half of that middle term, going to give me r plus 10 quantity squared. And it already said minus 40. What am I adding in the middle there? I'm adding 100. So in order to compensate for adding that 100, I have to subtract that 100. So the final answer is r plus 10 quantity squared minus 140. And if you multiply that back out and do the adding, you'll get the same thing. Y squared minus 3y plus 10. Now this one's going to challenge us a little bit because we got to deal with fractions. If I take half of 3, that's 3 halves. So I want y minus 3 halves squared. I had the plus 10, so to compensate for adding 9/4, I need to subtract 9/4. So that's going to give me y minus 3 halves squared, and 10 is really 40/4 minus 9/4 is 31/4. And that's my final answer. All right, so the process here is very important because you should always be able to go back and check that your answer worked. For instance, in this one I would have gotten r squared plus 10r plus 10r, which is 20r, and then plus 100, but then I subtracted 140 at the end, and did that give me back my original expression? Yes, it did. And I'm just realizing you have a c there and I have an r. Oh well. Okay, let's go down and try these that get a little bit harder. So what is a half of 3/4? A half of 3/4 is 3/8. So I'm just going to go ahead. J minus 3/8 quantity squared. And I had this 3/4 there, so what do I need to compensate by that I added or subtracted inside my parentheses? I need to compensate by 3/8 squared. Well, 3/8 squared is 9/64. So then I have to subtract out the 9/64 that I added in. And if you do the math and you deal with the fractions, which I know you don't like, but they are here to stay, you get j minus 3/8 squared. 3/4 is 48/64 minus 9/64 is 39/64. Let's look at 6. This one gets towards the algebraic conception of numbers. So really this one's asking you if you totally understand what we're doing right now. Well, basically what I have to do is take half of b. That's going to be x minus b over 2, right? That's all I'm doing. In every case I'm taking half of the middle term. I'm squaring that. I have my constant at the end, and then I actually have to subtract out the b over 2 quantity squared. So it's going to be x minus b over 2 squared plus c minus b squared over 4. And believe it or not, that is your final answer. How about z in number 7? You want to try that one on your own and come back and check? Go for it. You might as well try 8 too. For number 7, I took half of 5, which is, I just left it as 5 halves. I'm squaring that, and then I have to compensate my 8 by subtracting out 25/4. So it is z plus 5 halves squared, and 8 is 32/4 minus 25/4 is 7/4. The next one they gave you a decimal. So those of you who like decimals got to try this out. So half of 0.6 is 0.3. So that's going to be x plus 0.3 squared. And I had 1, but then I need to subtract out not 0.9. 0.09 is 0.3 squared. So it's x plus 0.3 squared plus 0.91. Final answer. Now, believe it or not, it gets even more complicated. What if the leading coefficient is not 1? Well, your favorite and mine. Can you unscramble this to a mathematical word? Why don't you pause here and see if you can figure out what mathematical word that is. The word is factor. Yay! Everybody loves to factor. So what do I need to do? Well, I need to factor out the coefficient of the first term, and I'm really only factoring it out of the first 2 terms. So let's see what that looks like. It's 2 times x squared plus 8x, and then I just leave the 3 at the end because remember I have to add and subtract to that 3 anyway. Now I can take half my middle term, so that's x plus 4 squared. I have my plus 3. 3, but you got to be really careful here, because normally I would just say, okay, I'm going to subtract out the 16, but the 16, remember, is being multiplied by the 2, so I have to actually subtract out 32, and my final answer is going to be 2 times the quantity x plus 4 squared minus 29. All right, let's try some more examples. I'm going to factor out my 3, so that's x squared plus 4x. Leave the minus 8 for now. I want to take half of that term, so that's x plus 2 squared. I have that minus 8, and really what happens here is I square the 2, giving me 4, and I multiply the 4 by 3, giving me 12. So I actually have to subtract 12 here, and my final answer is 3 times the quantity x plus 2 squared minus 20. Why don't you try number 2 on your own, and then we'll come back and do the harder ones. Number 2, you should have taken out a 4. That gives me p squared minus 3p. I leave the 13. I take half of the 3p, which is 1.5, and I did that as minus 3 halves. You could have done 1.5, doesn't matter, squared plus 13. What am I doing? I'm squaring 3 halves, which is 9/4, and then I'm multiplying that by 4. So my way actually worked out kind of nice. I just have to subtract the 9. That gives me 4 times the quantity p minus 3 halves squared plus 4. Number 3. This goes back to what is a factor? If I want to factor out 1/2 from this expression, what am I really doing? I'm taking out the 1/2. So somehow I have to multiply something by 1/2 to get 3. What do I multiply by 1/2 to get 3? I multiply 6 by 1/2 to get 3. Essentially, I'm dividing 3 by 1/2. Remember when we did factoring, it's the same as dividing. What are the factors of 10? Well, one of the factors of 10 is 5, so that means the other one has to be 2, because 10 divided by 5 equals 2. So we're essentially dividing that middle term by the leading coefficient, and then I have the minus 4. So it's 1/2 times y plus 3 squared minus 4, and then I'm going to square the 3, giving me 9, but I got to multiply that by 1/2, and that gives me, I have to subtract out 9 halves. 1/2 y plus 3 squared minus 17 halves. Number 4. Again, I have to divide 3 by 1.5. If I divide 3 by 1.5, because I'm factoring out a 1.5, what is that going to give me? 3 divided by 1.5 is 2. So minus 2n plus 6.5. And then I want to take half of that middle term, so I get 1.5 n minus 1 squared. I know I square a 1, I get a 1, and multiply 1 by 1.5, so I have to subtract 1.5. So that gives me 1.5 times the quantity n minus 1 squared plus 5. Number 5. Factoring a 1/3 out of 4. If I factor out a 1/3 out of 4, what does that give me? 1/3 times what equals 4? You should have a 12 here. Then I'm going to take half of that term, v minus 6. I want to square that. So if I square 6, I get 36. And 36 times 1/3 gives me 12, which means I have to subtract 12 here. So it's going to be 1/3 times v minus 6 quantity squared minus 2. The last one, hooray! This one's actually a little easier. We're going to factor out a 3. I get x squared minus 6x, and then my minus 2. Finally, take half of that middle term and square it. If I square it, I get 9. 9 times 3, 27, so I have to subtract 27. 3 times x minus 3 quantity squared minus 29. Woohoo! Great job! I know this was very complicated. We will practice a lot more, so hold on to your hats and have a great night.